This is National 5, it's the Applications Unit Assessment. We're looking at Standard 1.1 and I'm going to use the Pegasus practice paper for this one here. Right, we're going to look at questions 1, 2, 3 in this session here. Standard 1.1, the questions you get in the unit assessment will be different from this, but this is what you should expect to see. Right, so first question here, a farmer wishes to spread fertiliser on a triangular plot of ground. So the diagram gives the dimensions of the plot, calculate the area of the plot to the nearest square metre. Right, so it's going to be an area question, so first thing I'm going to do is look at my formula sheet, and in the formula sheet I should find the area of a triangle, and that should be a half AB sine C. Okay, so the triangle's not labelled up, so what I'm going to do first of all is with the angle here, I'm going to label this angle up here. Okay, C, and call this one A, call this B. Okay, remember what I need for working out the area. I need the angle and I need the two sides that are adjacent to that. So, and I've got that, so straightforward, I'm going to just do it. Right, so substitute in, so remember across from A will be A, across from C is C, and across from B is B. Right, so a half, 44 and 35, and it will be the sine of the angle, which is 58 degrees. So I'll just punch that whole thing straight into my calculator, making sure my calculator is in degrees, and what I should get out there is 652.977 and a bit more, and that will be square metres. And what I'll do is I'm going to round it to the nearest square metre, which should give me 653 square metres. That's the question complete. Marking for this one here, I'm going to get 2 marks for this, so I'll get 1 mark for substituting this in correctly here, 1 mark for getting the correct answer, rounded to the nearest square metre. So we're looking for out of 2 on this one here. Next question, okay, question 2. The diagram shows the paths taken by 2 runners, Barry and Charlie. Barry runs 350 metres from point S to point R. Okay, so and Charlie runs 300 metres to position T, and this will be position T up at the top here. What is the shortest distance between the 2 runners? So I'm looking for this distance that's here, and the question also helps me out, it says the distance TR on the diagram that's here. Okay, so what I'm going to do is I'm going to set my triangle up again. So I've got the vertex here, which is S, so across from that will be a small s, from the T will be a small t, from the R, small r, and that just helps me set things up. Now, usually what I look here for is it going to be a sine rule question? So I need an angle and I need to know a side across from it, so no, I don't have that. So it's more than likely going to be a cosine question, a cosine rule. So what I need for a cosine rule question, to work out this side, I need the angle across from it and I need the adjacent sides. Okay, so I've got that, so I'm going to set that up. In the formula sheet, you'll see the formula for the cosine rule. I'm going to set it up with S, T and R instead of A, B and C. So it's S that I'm interested in. So S squared is equal to R squared plus T squared minus 2RT, and that will be cosine of S. And that there is our cosine rule. And you'll just find that in your formula sheet. From there I'm just going to substitute our values in. So I've labelled up the sides, so R is to 300 there, so 300 squared plus the 350 squared minus 2 times 300 times the 350, and that's going to be the cosine of S, which is the 12 degrees that we're given there. What I'll do, fire that into my calculator, and what I should get out there is 7089 and I've got some numbers beyond that there. Okay, and what I'm going to then do is, I know that that's going to be S squared, so S is going to be the square root of this here. I'm just keeping all of that in my calculator as I work through here, and just taking the square root of my answer, which will give me 84.196, and that's going to be in metres. Yep, metres. And I've not been asked it to round to anything in particular. What I will do though is I'll just put it to 1 decimal place. That'll be in metres. That's just to 1 decimal place. Okay, and remember there that rounding is not required for a mark, okay, because I've not been asked, but that's a sensible one that I'll go for there. Okay, let's look at the marks for this question here. I've got 1 mark for knowing to use the cosine rule there, 1 mark for substituting incorrectly, 1 mark for getting this number here, and the final mark for this one here. So in this question, out of 4 marks. Right, so let's look at the third and last question in this assessment standard, the 1.1. What I've got is an orienteering course. There are 3 checkpoints, U, V and W, as shown on the diagram. W is 220 kilometres from V, okay, and 400 kilometres from U. Calculate the bearing of W from U, and that is, you know, a bit of help here again. We've got the size of angle NUW in the diagram, and we'll give our answer to the nearest degree. So what we're really interested in doing is finding out this bearing here, okay? And if I didn't get that bit of help there, that's really what I'm interested in doing, calculating the size of the angle there, or really the bearing that's in there. Okay, so let's go ahead and see how we can solve this one. So I can't directly go and find that out. So what I'm going to have to do is step back a bit and try and find out what I need to try and find that angle that's going to be there. So the thing that I would need to find that one is this one here. If I know that angle, I can subtract it from 180 degrees and I can find the bearing that's in here that I've asked for. So just looking at the triangle that's given then, what I can do is I can look and see if that's a sine rule question first of all, because it's not a right angle. I need an angle and the side across from it. Yep, I've got that, and good. For this angle here, I've got the side across from that as well. So what I can do is just set up the sine rule. So what I'll do is I'll use the sine rule. Okay. And what I'll do is I'll just use, instead of using the letters, the A, B and C that are given in the formula sheet, I'll just use the letters that are given here. And I'll start with that one because that's the one I'm trying to work out. Also, I'm just going to flip the formula over and I'm going to start with the angle on the top. So I've got sine U over U is equal to sine V over V is equal to sine W over W. Now with W there, I don't know anything about that at all, so I'm not really going to use that one. I'm just going to use these two in my calculation here. Right, so let's do our substitution. And U is going to be the side across from here, V is the side across from there, and W is the side that's there. So what I've got then is, I've got U being 220. And on the top here I've got sine of V, which is 125, so sine 125, and below that, let's see, we've got the 400. Okay, from there, if I'm dividing here by 220, I'm just going to take that over to the other side and multiply by it. So what I have is sine U is equal to 220, sine 125, all divided by 400. What I'll do is I'll put that into my calculator and see how that works out. Make sure your calculator's in degrees again, okay, and what we'll do is we'll just work that one through. So what I'm going to do is I'm going to go 220, and what we'll do is I'll times that by sine 125, close the bracket, and I'm going to just press equals. So that gives me my top line. I'll then just divide that by the 400 that's on the denominator, and that should give me 0.45. So here we go, 0.45, and I'll just take some more of the numbers, so it'll be 0.5336, okay, and we've got a bit more of that. I'm going to keep that answer in the calculator, because what I'm going to do is I'm then going to find out what U is equal to, and remember, when I'm working out the angle, I'll take the inverse of sine for that angle there, and it'll be the inverse of the number that I've got there. Remember, I've just left that in my calculator, and that should give me, if I just go for the shift sine or inverse sine of the answer, and then I'm just going to take that as 26 point, just take these guys down, and that's going to be in degrees. And what I'll do is I'll just, I know that I'm going to have to give my answer to the nearest degree, so let's go for 27 degrees for this one here. So remember what that is, that's the angle that's in here, so that's 27 degrees in here. And what we're saying is that what we can do is to find out that bearing, the bearing in here is, I'm going to subtract it from 180. So the bearing of W from U, so W from U is going to be equal to 180 minus 27 degrees, and that should give me 153 degrees to the nearest degree. Okay, so in there, 153 degrees. Okay, so that's that question there complete. So let's see where we're going to get our marks for this question here. There's going to be a mark that we're going to get for this question here, but the mark's not, it's not just a normal mark for here. This is going to be under standard 2.1, and that's because it's a strategy. Okay, so I've got a bit of a strategy mark there, so that's going to help me with one of my other outcomes for this standard. What I'll get is, I'll get 1 mark for getting down to here, so that will be the 27 degrees, and the further mark would be for that one there. So what we have is, we have a 2.1 mark, okay, so that's out of 1, and what we've got is, we've got a mark out of 2 for the rest of the question. So there's 3 marks for this one here. And that's the end of standard 1.1. And what we need is, we need half marks to pass this.